Hello and welcome back to the TEDAC build series. Welcome to a new episode. Off camera, I've done some work for the sake of time and because it's not as relevant for the build process itself. As you can see, I've already attached the grips to the enclosure. To do that, there's 6 holes here to the side, but I only used 3 screws. That's more than enough. These are M3 by 20 screws, and these hold the grips perfectly fine. As you can see, the wires, I've not done anything yet to them because I want to explain what do we need to do with them. What I did though is connect DuPont connectors to the ends of them to advance in the process. But they are not connected, and I will explain how are we going to connect it in this video. So today we will be installing the Arduino Pro Micro and connecting these wires to it. So as you remember, the left-hand grip has 5 wires. If you are using shift resistors, it's going to be 4 of them if it's port expanders. And the right one has the same wires, 4 if it's port expanders, 5 if it's shift resistors, plus the 2 analog ones, which are the green ones. And also, if you remember from the previous video, if you are using port expanders, you should also have at the very least 3 more wires coming in. These are digital inputs that you need, we are going to need if we use a port expanders, because the port expander is going to be in. We do need those 3 digital inputs as well if you are using shift resistors, but today we are going to be installing a 4th shift resistor. There's 3 shift resistors inside here. We are going to install a 4th one somewhere in here. I don't know yet because I did a little bit short wires, so we will see where we'll put it, but we will connect the 3 here to this one. So this one will be the last one, and this one is the one that will be connected to the Arduino. And those 3 wires that if you use port expanders are coming out of the grip are going to be from here. So there's 8 inputs here. I'm going to use 3 in a future video, but we will have it available somewhere in the enclosure, so that's fine. And we are also going to connect these 2 switches. So in the previous video, let me show you what I did to the enclosure, because I showed you the enclosure, and you saw a lot of wirings and boards and everything, and you probably don't know what they are. But let me do that now. So one thing that the enclosure has here at the top, there are 3 holes that are for switches, and these are completely optional switches. You don't need them if you don't want. You could use, like I have, for instance, 2 position switches here. It could be a 3 position switch, it could be a button, or it could be nothing at all. I plan to use these for snap views maybe, or SRS, or whatever you want to. These are just additional inputs because we have leftover pins, so we might as well just use them. But you cannot use them if you don't want them. You don't need them. So these are optional. So let me show you what I did. As you can see, the grips, as I mentioned, are not connected. These wires here is essentially, this is the USB. So this comes from here. It's a USB-C female port in here. And this is basically a female to male extension. So there's a female port like this one inside here, and this is a male port. So basically it's a USB extension. It's for me to be able to place the Arduino wherever I want. So I just plug this and place the Arduino wherever I want. So this is one thing. And everything else, it's only for the LCD. So if you are not building your TEDAC with an LCD, which is a perfectly valid option, whether or not you play in VR, even if you don't play in VR, you can still use this as a controller and use the screen in game in your monitor. So you don't really need an LCD. I just like to have it because it makes it cooler and whatever, but it's not necessary. So this here is the control board for the LCD. It's like this one, and you can see it has the input power jack, which is this one here. It has the HDMI out. It has I don't use VGA or this is the audio input, so I don't use any of that. I only use the HDMI and the power in. And as you can see, the way the board is placed, and because I want the HDMI and the power to come from the back, which would be this, the back would be this. I've also used a 90-degree HDMI, so male to female HDMI, like this one. So it's coming out of the back, as you can see. There's the HDMI, and this is just a support, because if you're going to be plugging in and out HDMI, or even if you don't plug it in and out, but I mean, you're going to be pushing this way the HDMI, you could pull this. So this is only a bracket to hold that HDMI 90-degree angle. And then there's a 5.5 barrel jack, like this. This is the power in. You need to plug in a 12 volt, at least 2 or 3 amp power supply for the LCD. And this is essentially connected from behind to the, come on focus, yeah, to these pins of the barrel jack. So essentially this is an extension of this barrel jack. And then down here, it's just the control, the buttons for the board. So you can see it has power, menu, plus, source, whatever. That's to control the LCD. So for instance, change between HDMI and VGA, and also this is coming out of here, right? So you have also the IR receiver for the control remote, because this LCD also has a control remote. I never use it. Once you set it up, like you set the contrast, the brightness, or whatever you want, and also the source as HDMI, it stays like that. So you won't really need to use this, but I mean, it's good to have it just in case for whatever reason it resets. So as I mentioned, I've added DuPont connectors to the ends of the wires, except for, I mean, I've done this for the analog, but not for the rest of them, because the shift register wires, which are everything but the green wires, so these ones here, are actually going to be connected here. So I'm gonna do that. I'm gonna solder, this is going to be in the in here. You can see that it says in, because it's coming from the out of the last shift register into the in of this shift register. And I will also solder some outs with DuPont wires. One thing to mention, and something else that we are going to do, as you can see, we have one VCC and one ground here. We also have another VCC and another ground wires here. And these are going to be common in here. We're gonna be using, I don't know if you can see, but the second pin to the right, this one here is a ground. The fourth pin is a VCC. We are going to be only using those two pins. And actually, in the screen that we will be doing in a future video, we will also have another VCC and another ground that we need to connect. So what I'm gonna be doing, I have, these are called breadboards, I believe, or proto boards. And this one in particular, the usual one, the normal one, looks a little bit like, let me show you how it looks. So I have another one for another prototype here. It looks like this. So you have individual copper pads for each hole. So this is what you would usually find, but you can also find them like this. So if you see, all these lines are connected. So everything that I soldered in this line is going to be connected together. So what I did is one of these. And as you can see, all these pins are connected together, all these are connected together, etc. And that's gonna, this is kind of maybe a power rail or whatever you want to do. So whatever you want to call it. So what I'm gonna be doing is connecting from the Arduino, let me see, ground and VCC to these top and bottom rows. So everything that I connect here will have VCC and ground connections to the Arduino. So I don't have to pigtail or solder wires together or anything. So I just can plug everything here. It's kind of like those wall sockets that have multiple, it's similar to that. And you may be wondering why do I have 4 rows? And that is because the shift registers, we are going to be using the same pin, come on, focus, for latch, which in my case it's labeled LD. Sometimes it's CS, sometimes it's latch, sometimes it's SH, but it's the same concept. Latch and clock are going to be connected to the very same pins. We will mention that later on, but they will be the same. So it's going to be only 2 of them because there's only 2 lines of shift registers. So I could pigtail the clock and the both clock wires together and plug them in. But since I'm already building one of these, why not just do a clock and a latch row as well? So what I'll be doing is the top row is going to be, for example, ground. The second row is going to be latch. The third row is going to be clock. And the fourth row is going to be VCC. And I'm going to connect the first column from the Arduino, and everything else will be connected to the same pins in the Arduino. So let me do that, and I'll show you what I mean. So before I go ahead and explain you what I did during the pause, a couple of things I forgot to mention. One of them is this switch in the back here. I didn't mention, but as you can see, it is already wired. In my case, this is for the backlight. So the green light that comes off from the back of the buttons, which is again optional. You don't need to do a backlight, even if you do screen or not. I mean, screen is optional, backlight is optional, and they are not tied together. But backlight requires also 12 volts as well as the LCD. So what I did is I hooked up a negative and a positive to, in my case, it's this switch here. It's a 12 volt switch as well. So I know these 2 pins are 12 volt and ground. So what I did is essentially tie them to a switch so I can turn on and off the backlight whenever I want with that switch, and then it goes to this DuPont cable. That actually I'm going to replace this with a JST XH connector, but I'll do that at another moment. But this is going to be connected to the PCB of the screen, and that's going to be powering the 12 volt required for the green LEDs for the backlight. Again, this is optional, and you could use this switch for another input if you want. The other thing is, we talked about this kind of power rail or whatever you want to call it. We are going to be using VCC, clock, latch, and ground. But you can also use this. This is useful also for port connectors. And instead of clock and latch, you would have clock as SCK and SDA data, because you are going to have to connect clock and data, and then into the Arduino. So yeah, you can use this for port expanders as well. So what I did essentially, as I mentioned, I connected the 5 wires of the shift registers in the right grip to a 4th shift register. So now I have 8 more pins to use. 2 of them I'm going to be using these switches, and the other 3, the ones that we will need further into the construction. And then I wired to the out. This is the out, as you can see. These connectors, which are the ones that are going to go to the Arduino. Same thing. And actually, I already connected them in with these cases 4 which are going to be in the power rail, and the individual one, which is the data. The yellow in my case is the data pin, which is going to be connected directly to the Arduino. We are going to use a different data pin for the right hand and the left hand grips. So again, left hand grip as well, for connector that is going to be connected here, and the individual data pin that is going to be connected directly to the Arduino. In the background here we have the 2 analog pins that I forgot to put a case to them, so maybe I'll take this one off and use it for the analog ones. And then I did this kind of extension cord. This again has the same order, so these two have the same order of colors. So we have red, blue, white, and black, red, blue, white, and black, and same here, same thing here, red, blue, white, and black. So what I'm going to do is, this is going to be the extension that it's going to plug from the Arduino. So I'm just going to do this like so, right? And then with the Arduino, to the other side, I have this, which is the ground and VCC, and I used a 3-pin connector, even though the middle is empty, because VCC and ground are separated by 1 pin. So as you can see, ground and VCC, and then blue in my case is clock for the shift register, and white is latch, and this is important. So the clock, which is blue in my case, needs to go to pin 15, which is this one here, and that makes it so latch is going to be pin 14, which is the one next to it, and there's going to be 4 analog pins available here. These are the analog pins that we are going to be using. So I don't know if you can see it on screen, but these 4 pins are A0, A1, A2, and A3, and those are the analog pins. And these 2 pins here at the very bottom, which are 15 and 10, we are going to connect the individual data shift register cable to them. It doesn't matter which one, so we will do that in later in the software. So, but this is important. Clock, if you are using shift registers, is going to be pin number 15. If you are using port expanders, you're going to have VCC and ground, obviously, and this is the same, these 2 here, but you're going to have SDA for data and SCK for clock, so clock and data. And in that case, SDA is pin number 2 down here. This one here is pin number 2, and pin number 3 is clock. This is important. So if using shift registers, clock is pin number 15. If using port expanders, SDA is pin number 2, SCK is pin number 3. Okay, we will have to install different firmware, and that's going to be another video, depending on whether you use shift registers or port expanders. So in my case, shift registers, clock is blue, and blue is pin 15. Now that I have this connected to the Arduino, next thing is going to be grab this one, for instance, and connect them with the same matching colors, right? So if I connect it like so, I'm going to have the same colors in the same rows. Same thing for the left grip, like so. And then the only thing that we have left to connect is the data pins for both sides, left and right. So these are the data pins. It doesn't matter which one is pin number 15 and which one is pin number 10. So just connect them however they go. And with that, now I know how much room I have to play, because I didn't cut my wires very long. So now I'll figure out where can I hot glue this? I'm gonna hot glue this to the enclosure. I also need to connect these two analog wires that I need to put this 2-pin connector in. I'm also going to connect to A0 and A1, and then depending on how long the wires are, I'm gonna hot glue everything wherever I can. So let me do that and show you the end result. Okay, so this is the end result. Basically, I've hot glued everything where I could. In my case, I cut the analog pins too short, so I had to glue the Arduino board here, but it's fine because the rest of the wires are long enough. I hot glued the additional shift register up on top here, and then the power rail or whatever you want to call this right in this corner, and everything is fine. It looks a little bit of a mess, but there's a whole lot of space. I mean, we are not gonna fill in this space, so it's fine. Everything is going to be covered, so don't worry about wires being a little bit all over the place. Last thing left to do is connect 2 switches to the additional shift register. I'm gonna do that, and then I don't think I need to show you that because it's very simple. I'm just gonna use the middle pins. I'm gonna connect them together, these middle pins, and then that is going to be into a ground of this shift register. And then one of the ends, and this is the thing with 2 position pins. So you can have these, switches. You can have these switches to act as 2 inputs or just one. If you connect only one of the ends of it, that switch is going to be an on-off switch, right? So it's going to be, let's say this is switch number 80, for example. It's going to be button number 80 on, button number 80 off. If you connect one wire to each end, and obviously it's going to take twice as much, but I could do that. We do have enough pins, but I could use, instead of 2 pins, I could use the 4 of them, each one of the end pins connected to it. That would be, for instance, button number 80 on, button number 81 on, and obviously 80 off, 82 on, 83 off. If I only connect, I am only going to connect one because I don't really need them. I don't really use that much the additional input. So I'm going to connect just one side of them, and it's going to be just on, off, 80 off, 81 off, on, whatever. So yeah, I'm not going to show that in camera. I'm just going to connect the middle pin to ground, and one of the pins, it doesn't matter which one, to one pin to here, one pin to here. So 2 pins of the shift register. I'm gonna have 6 more pins available. I only need 3, but it doesn't matter. There's gonna be some leftover pins, not used pins. That's fine. So that being said, I think this is going to be it for today. Next episode, we are going to start with the screen. So yeah, I already have it printed here, and also the PCB. So in the next episode, we will be working with, mounting the PCB. But before I do that, I need to record another video, which is not, it's connected to this build, but it's not directly or exclusively for the TEDAC build. So yeah, there's gonna be like an intermediate video before the next episode. With that being said, I'll try not to take as long as I did to record the next one. So thank you much for your patience, and see you in the next one. Thank you for watching.